it's a bird, it's a plane. No, it's a flying lizard?
In this paper, scientists were studying flying lizards. Well, not actual flying lizards, but lizards that lost their grip during really high winds in a hurricane, which, it turns out, is a form of natural selection. And the scientists who were studying this, they had to use significant figures to do their research. In 2017, the scientists were working on a different research problem that required them to measure lots of lizard body parts for lots of lizards on 2 islands in the Caribbean. Right after they finished collecting the measurements, the hurricanes Maria and Irma battered the 2 islands. The scientists saw an opportunity and went back to the islands to measure the surviving lizards to see if the hurricane had led to short-term natural selection. With the data the scientists collected beforehand, they realized the storm had wiped out the lizards with bigger femurs and smaller toe pads, since those were the ones that had a harder time clinging to the trees, leaving behind the lizards with smaller femurs and larger toe pads that were better equipped to cling to the trees.
To measure leg length, they used a digital caliper which was accurate to the 100th place. Notice that the caliper was more accurate than the 10th place, but less accurate than the 1000th place, which makes a big difference when you're counting for sig figs.
Sci-fi?
No, sig figs, short for significant figures.
Oh, I get it.
A significant figure, or sig figs, is a number that shows the degree of preciseness of the measurement. For example, if the scientist said that this lizard's femur is 10.798442 centimeters long, then that implies that they measured it to the millionth decimal of point of accuracy, which, by the way, is on the scale of 10 nanometers, not something you can measure with a caliper.
So the scientists only report the 2 digits after the decimal, since that is the limit of the caliper's accuracy.
A measurement can only be as precise as the tool that is doing the measuring. For example, if you're using this ruler, the smallest division is 0.1 centimeters or a millimeter. So if you measure something that looks like it falls between 2 lines, you can't write down 7.45 centimeters because the ruler isn't accurate to the 0.05 centimeter mark. You can only report 7.4 centimeters. But if you're using a digital caliper, you can report 7.45 because the caliper is more accurate than the plastic ruler. So make sure you don't report a more accurate number than what your device can actually measure.
Significant figures follow 3 basic rules. Number 1, non-zero digits are always significant. Think about numbers like 319 or 12.25. All of the digits in these numbers are non-zero, so they are all significant.
Any zeros between 2 significant digits are significant. For example, in 808 and 7.02, these zeros are significant. The reason that you know that the ones place is accurate is because there is a non-zero number in it. So you know that you measured all the way to the ones place.
Third, a final zero, or trailing zeros, in the decimal portion only are significant. Zeros are significant at the end in the decimal place. For example, 7.800. The reason is that you measured it with a device that can measure to the thousandth place, and the number you got was 7.800. As opposed to 7.812. Zeros are non-significant when they are between a non-zero number and the implied decimal, like 7,800,000 or 0.000000078.
Now let's take a look at how to apply sig figs when you're doing multiplication and division. So let's say you multiply 7.93 centimeters times 24.1 centimeters. The calculator will calculate the exact answer, which in this case is 191.113 centimeters squared. But the problem is, each starting number only had 3 significant figures, so your answer can only have 3 significant figures. Using sig figs, the answer here should be 191 centimeters squared.
Don't just use the numbers that the calculator spits out, because the calculator will always give you the most accurate answer, but your measuring device may not actually be that accurate. Always remember to use the same number of sig figs in your calculated answer as in your starting numbers.
But what if your starting numbers don't have the same number of sig figs? In that case, whichever number has the least significant figures is the number of sig figs you should use. So let's say you multiply 7.93 centimeters times 24.128 centimeters. The calculator tells us that the answer is 191.33504. but you know that's not an accurate answer because it has more significant figures than your starting numbers.
But wait, 7.93 has 3 sig figs and 24.128 has 5 sig figs. How many sig figs should the final answer have?
The answer is to always use the least amount of sig figs in the numbers you started with. Since you have to drop some of the digits from the answer, be sure to follow rounding rules. If the first digit that you drop is 4 or less, just drop the digit off. If the first digit you drop is 5 or higher, round up on your last sig fig.
Let's do some division. 7.83 divided by 0.02 equals 391.5, correct? No, it should be 400. Why? Because the number 0.02 has the least significant figure, 1, so the answer must also have one significant figure. The rules are different when you're using subtraction and addition. In that case, your answer should have the least number of sig figs in the starting number only in the decimal portion. For example, 783.238 plus 5.2 equals 788.438. But since one of our starting numbers only had one sig fig after the decimal, the answer should be 788.4. So it also has one sig fig after the decimal. But what if you come up with an exact number like 200? How do you know it's not just being rounded up? To make sure 200 is the exact number you came up with and not just a rounded up number, you should write it as 200 with a decimal point at the end.
And with that, you have learned the importance of sig figs, sig fig rules, and how to use them in math.
Maybe next time you're using sig figs, perhaps you'll be conducting an experiment as cool as the scientists who studied the change in lizard anatomy.
What will you use sig figs for?